Hello, welcome to Tracing Adventures from Pull Request to Production. I am Paige Cruz, aka PagerDuty with an I. That's where you can find me on most social media. Today, I want to talk about tracing our CI/CD pipelines. So let's start with a little scenario. It is called Can I Deploy? It is Wednesday at 4:30 p.m. Dina, the developer, has just finished up her work for the day and wants to get it merged in so she can deploy it to production tomorrow and let it bake all day Friday before heading out for the weekend. Olive, the ops engineer, is really looking forward to the end of the day when she can log off because she has been on support duty all week and it has been overwhelming with nonstop interruptions. But unfortunately for Dina, there's one PR check that keeps failing mysteriously, and the error doesn't look like it's coming from any changes she's made. But she knows that ops can help her out. So she heads over to the ops channel and asks, why is this check failing? And noting she's really got to deploy this before the end of the day. She's got this plan. She's got to get this deployed to prod. And Olive, the ops engineer, is like, well, have you tried rerunning it? Which, as silly as it sounds, resolves about 70% of these types of drive-by requests. But Dina has done her due diligence here and replied, yes, in fact, she's tried rerunning it 3 times and is still getting the same weird error. And Olive sighs. She's a little annoyed. It's at the urgency for this request, considering there's 30 minutes left in the workday, and she doesn't really know how long it's going to take to figure out this issue, let alone get it fixed. And so she writes back, I'll look into it. But all that Olive, our ops engineer, has to start this investigation is a link to a failed pipeline run. Her alerts channel for the CI/CD infrastructure that this is running on is quiet. There's not an issue with compute capacity. And a quick check on the deploy pipeline overall for the past hour before and after Dina's changes, we're passing just fine for this check. And she starts to wonder if it was Dina's PR that actually introduced some sort of misconfiguration. She wonders, why is ops always the one that has to do these investigative deep dives? Well, end scene. So speaking in generic terms, dev and ops, we have distinct perspectives and we use different signals to understand the CI/CD pipeline or the health of a system. And it's not really always straightforward to know who's responsible for an issue. And these investigations can be pretty lengthy, especially if it's an error that's not really originating on your side of the table. And so I like to imagine myself in both people's perspectives. And so developers are looking at the system from this singular pipeline, this one application, the PR checks running on this repo point of view. When they report issues, it's likely, mostly always a reactive response to something that went wrong, especially tied to a commit they're trying to get out the door. So they're kind of reacting to the errors that pop up. While, on the other hand, ops, SRE, infra, whatever you call it, really wants to look at the whole system holistically, all of the infrastructure, all of the pipelines and repos, and are often running support for this internal platform of the CI/CD system. And they get a lot of questions and frustration from end users, and sometimes they have to explain, actually, no, it was your change, or here is the documentation that explains how to properly configure this. But ops always wants this kind of helicopter in the sky view. We care more about, are all of our nodes healthy and online? Are all of the pipelines running efficiently versus any particular single one? But in situations like this with Dina and Olive, without this ability to sufficiently observe the platform and get good signals or telemetry from your pipelines, you can really end up playing this blame game where it's the platform is now the new, it's the network, where developers point to ops and kind of blame the pipeline, the CI/CD system, and it really doesn't take much to lose their confidence and their trust. And just on the other hand, operators can easily fire back. Actually, it was totally your change. Why don't you know how to use this system? It's been running for 5 years or whatever. We get in this back and forth tussle when we don't have sufficient observability and visibility to help us scope down what and why things are going wrong when they do. And this is just the opposite of healthy collaboration, this tug of war. And so to borrow this concept from cloud computing, the shared responsibility model, I think CI/CD pipelines are kind of a perfect blend here where we have a little bit of overlapping. We have a shared interest in that we all want good code to get out the door and hit production. But when it comes to developers, they're specifically focused on their application code changes, writing tests, linting, package management, version upgrades for frameworks and languages. Potentially, they're responsible for defining the deployment pipeline and configuring and environment variables and secrets. And then obviously, they're the ones hitting the button to deploy. And ops, our lens, is really the underlying infrastructure, the compute nodes, the available capacity to run pipelines, the reliability and availability of that platform, and as well, these days, kind of cost efficiency. How much are we spending financially on running these things? But either way, there are still some issues that fall into that thick dotted line in the middle where you're not quite sure who's responsible, but at the end of the day, the problem needs to be solved. Dina's code needs to get out the door. The feature needs to be deployed. And so how can we work together and collaborate? Some of the things that fall in this gray line are who is responsible for excessively long pipeline durations? Well, it could be a very inefficiently written test suite. That would fall on the app side. It could be that your pipeline is stuck in a queue waiting for available node capacity. That's kind of more of an ops thing. But at the end of the day, we want to get this stuff out the door. So there's a lot of things that fall in that gray line, which is why I think that tracing and telemetry can help. They're not helping you solve who owns what, but it helps give you the data you need to understand the scope of an issue and pinpoint where to optimize. And optimization, pipeline optimization, is another thing that falls into that gray line. Who's really responsible? Well, who has the most sufficient context and expertise over that particular pipeline, or dev and ops sometimes. I would work together to say, I know the pipeline configuration language very well. You know Ruby, how to run Ruby tests super well. Let's work together and write an efficient pipeline. So we want to work together. We don't want to do a tug of war. And so let's consider the path to production. It can be a very long and winding journey. That includes many steps. Of course, we start with opening a PR. I really hope you have a human that is reviewing your PRs, someone to just double check that everything makes sense and looks good. We, of course, have the merge, which then kicks off a deploy to any number of pre-production environments, at least one. And at any point along this long journey, many things can go wrong, stemming from the change itself, the platform, the CI/CD pipeline availability, or the underlying infrastructure. And really, the first environment that all changes land in is typically the worst to troubleshoot in. This is typically your staging environment, because it's where all new code goes to get deployed. It's the infra teams, also their staging environment to upgrade new patches and test things out before production. And generally, there's just so much noise and changes going on, can be really hard to troubleshoot. And when you have something that was successfully deployed in all your pre-production environments and then suddenly fails in production, you then play this game of spot the difference. What's different between the successful staging deploy and this unsuccessful production deploy? What's the difference between those environments? And it can be very tricky without great data to understand the nuances and what has changed. And on some level, we tend to talk about the environments that are your integration, your staging, and production. but I can actually think of two more kind of hidden environments, which are, of course, your local development environment and your CI/CD pipelines, where your PR checks are run and when your deploy pipelines are run. That in and of itself is a bit of a different environment than some of these other ones. And that difference I find is the causes when you don't understand what makes that different versus running locally on your laptop or running in staging, not understanding that difference between how your CI/CD pipelines are executing can lead to some of that contentious battle. So it is not realistic to expect our devs to troubleshoot issues with the underlying infrastructure, just as it's not realistic to expect us as operators to dig in and exactly find the application misconfiguration or to find the flaky tests or fix them in a framework that they're not experts in. So what can we do about this? Well, tracing our pipelines. I think that traces can bring people together. Just as traces span service boundaries, they also span team and role boundaries. And I can hear you saying or thinking, but we have metrics and logs. We have data already about our pipelines. And metrics are great for monitoring, setting thresholds, alerting on things like pipeline duration is over 1 hour, or a particular node that's ooming when a particular pipeline step runs on it. But metrics lack sufficient metadata and context to truly debug issues, which is why you're often going to scroll through a ton of logs that provide that detailed context. And you'll still be using logs to troubleshoot, and you'll still be using metrics to monitor, even in a tracing world. So why even add it? Isn't it just for giant microservices and kind of cloud native deployments? Well, in my experience, I found that CI/CD tooling that's sort of off the shelf, the monitoring and data that they provide out of the box is really great for individual runs and great for individual repo views of the health of a pipeline. But I'd struggle to answer questions like, did all runs of this pipeline fail on the same step? Did all runs fail for the same reason? Did this version of Ruby show performance degradation across all of the services that upgraded? Did this failure occur only in a specific branch or on a specific node? And the beauty of tracing is that it gives you the where, so you can focus on the what and the why. And to pan between that high-level helicopter ops view down to the app dev driver in the driver's seat view and kind of anywhere in between. And how does it do that? High level, quick synopsis of a trace. It is a DAG, a directed acyclic graph that represents the workflow. If you've opened up Chrome Developer Tools, the network tab, and you see the waterfall, that is a trace. That's tracing one request or the many requests it takes to load a modern web page these days. There's two kind of views, the waterfall view, and then on the left, we see the kind of topology or the sort of service map view, where in our case, for a pipeline, we would have a route span that represents the entire pipeline run and every step of the pipeline as its own span. And pipelines are the perfect thing to model as a trace because we've got these discrete steps that are run in a certain order, and we can support parallelism and showing concurrency as well. And so in our case, our build stage might consist of some sub-steps like checking out a repo, linting, building an image, and pushing to a registry. And why the power of tracing here is we not only get data about how long the entire pipeline took, which matters to developers for velocity, but also we know how long each step took on the way, which is great when it's time to optimize to say, oh my God, our builds are creeping up. Our build time used to be 20 minutes and now it's 40 minutes. Why? Well, a trace can show you which step is really the cause of that. So if we look at the trace waterfall, in this case, your eyes, where humans are very great at visual parsing, we can see scanning our image is taking forever. It is in that critical path. And maybe security engineers just added image scanning. So you could give them that feedback, hey, here's the before and after of you adding that step. We really need you to trim down that time or find some way to optimize it. And now it's a very, very simplistic example. To borrow a screenshot of a traced Jenkins pipeline, you can see the more complex and real world things get, the data is so dense. And that is really why I love traces, because there's all those little arrows where you can collapse the context, but that overall view of the colored bars shows you, I wonder why this step is taking a long time. Or why did this thing only take 2 seconds? I thought the test should be taking 5 minutes. And as a side note, this is the Jaeger UI, which is an open source UI for tracing. I believe the only open source UI for tracing. And if you wanted to try this out, they have a handy all-in-one Docker image that you can use to just kind of experiment with. But you can see, if I just had a metric chart that said, pipeline duration or pipeline success or failures, and then I had a whole laundry list of logs associated with each pipeline run, it'd be really hard for me to pull together a picture of what was happening that the trace gives you out of the box. We still want metrics, we still see logs. Maybe you find a step in here that is taking a long time. Now that you know that step, you can hop just to the logs for that section and really take a closer look instead of scanning a whole bunch of pages. So from a platform perspective, if you happen to be running a CI/CD system that's open source, or you're paying for a vendor that is OpenTelemetry compatible, you could also get a trace, not only from the app dev's perspective of running the pipeline, but also from the platform's perspective. So to run a pipeline, you probably receive a webhook, you got to schedule that pipeline to run somewhere, and then you're running each step maybe in containers or something. It's also really helpful for you as the operators to understand how efficiently the service that you're providing developers is and where it could be better. And maybe if things are queuing up, you should look at expanding your capacity. And tracing can help give you the data to inform these decisions. And so if we look at the path to production, we would have a trace for our PR check pipeline and a trace for each time that we're deploying to a different environment. But separate traces doesn't mean disparate data. You can compare the traces, and as long as there's a common attribute, like say a SHA that you're deploying, you would be able to find all the traces with that SHA and see, what was the difference between the failed production deploy and the successful staging one and why. And with the tracing, you can zoom in to diagnose. And so this phrase comes up a lot in tracing and observability, slicing and dicing your data. Like, what does that mean in practice? And like from the earlier example, when there is a problem running a pipeline, you need to really quickly be able to understand, is this problem just like all of the operators, like, is this just impacting Dina in this repo? Is this impacting one team's services? Is this impacting everything? Is it the underlying Docker image that we just upgraded? Like, is that busted? It's really answering, is this isolated or is this widespread? What is the scope of the issues and the errors? Yeah, and the slicing and dicing all comes from the attributes that you're able to throw onto a span, those little individual units of work. And so there's some common things you would throw on, like a SHA. I think people love to throw on, like, I like to do the version number, at least of the language or the framework, the team that owns it, any major features it supports. And there is, I'll talk a little bit about OpenTelemetry's idea of CI/CD semantic attributes, but it's really what makes sense for your organization. And the best part, I think the part that's the funnest about observability, is getting to become like a data detective, because once you have access to a rich data source, you get really curious and you get to start asking questions like, are developers needing to frequently rerun pipelines? All have said, oh, just try rerunning it, that fixes it most of the time. Well, if I have to always know that I have to rerun my pipeline 2 or 3 times before it succeeds, that's actually wasting a lot of developer time and energy. And they're like optimizing that and fixing that and addressing whatever is causing it would be a valuable project to take on. And you would have the data to kind of show that to the organization or your boss. You might know which pipelines need to be rerun, what teams, maybe there's a team that needs some training on the pipeline configuration, like how to set it up. It's also great for time comparisons. Is our pipeline running slower than last month, than last quarter? Has that build time been creeping up on us? Was there a deploy that introduced significant latency? Or is a particular dependency, like an external smoke test provider, failing often? The cost piece of it comes into like, is it worth getting bigger servers or asking developers to parallelize the work and split up their tests over multiple nodes? When you're undergoing cost optimization efforts, you should definitely be looking at your CI systems as well, because if you're rerunning a pipeline a bunch of times, that is, I don't know, kind of wasting compute. So how do you get started in this world? Luckily, there are many efforts underway to trace CI/CD platforms. Of course, OpenTelemetry I've got to talk about. They are the open source tracing instrumentation standard for generating, collecting, and exporting this data. And they are natively supported by all monitoring and observability vendors at this point. So this is the place I would recommend people start looking to see if whatever system you're using has an OTel integration. This is a little diagram. Today we're talking about traces, but if this opens your eyes to the world of OpenTelemetry, the collector is another component you might want to look at. The collector can take in metrics, it takes in traces, logs are coming, it's experimental. And so when we think about OpenTelemetry, if you remember write once, run anywhere, OpenTelemetry is trying to be instrument once, observe anywhere. And at a high level data flow, what would this look like? You have your CI/CD system, you would have some OTel SDK or integration that you would set up. It would send on to a collector and then to some observability backend or UI or vendor. The collector is kind of an optional component, hence the asterisk, because some vendors just offer an endpoint for you to send traces. Another question that comes up, so check, what do we use? We're using OpenTelemetry. Do I go DIY? Do I manually instrument, or should I use automatic out-of-the-box instrumentation? If your platform, your CI/CD system and your pipeline already supports OpenTelemetry, oh my God, just use the auto instrumentation and make sure that you're adding the attributes that are important, specifically like team this, team owning team is this, and maybe if you do departments or divisions, tech ops versus, I don't know, feature A team. Those are the things you want to know who, you want to add that who owns what context, but just use auto instrumentation where you can. Otherwise, you'll do some manual instrumentation. What that looks like is wrapping each build step or each pipeline step in a call to create and send a span. Your options are the OTel CLI, trace pusher, or the OTel registry where you can find your stack. Very quickly, like what this looks like, you've got to have some place to send your data. So you'd send an endpoint, set up an endpoint. And the important thing here is like, what would you need to do to get all this beautiful, rich data? You need to get a start time. Each span has a start time, an end time, and an ID, a unique ID. And here, we're stating the service name, the span name you want to be able to make this stuff searchable and useful. Name it after each step and after each pipeline. And yes. And so then if you're doing it manually, one thing to be mindful of is generating that trace ID. The OTel docs have some more specifics around the requirements of a good trace ID. And then it's sort of adding a before and an after. So keep the pipeline as is, just add these before and after steps so that you start the span and then you end and send it off. And then, yeah, send the trace. Once the pipeline is done, make sure that you've sent everything off. Integrations that already exist, Ansible tracing callback. Oh my God, if I was still using Ansible, I would have thought this was the coolest thing to figure out what my playbook was doing or get that waterfall view to see where I could optimize things. There's a Maven extension. PyTest also lets you trace your tests, which is very cool. And then this is what the OpenTelemetry registry looks like. All of those beautiful languages. Definitely recommend checking that out. Native instrumentation, your options are a Jenkins plugin. If you're using GitHub, a GitHub action step. Concourse CI is experimental, but definitely hop on that if you are using Concourse and interested in this. And then Zool is not something I've used, but they have currently have a proposal out for investing in OpenTelemetry traces. And this brings us finally to the OpenTelemetry proposal for officially including semantic conventions for CI/CD observability. An OTEP is what it's called when we say, hey, we would like to add this thing to OpenTelemetry. What do you think? And a lot of people discuss. And so this is your time to have your voice heard. If you've been digging into pipeline data day in, day out, and you've got opinions, go ahead and add them to this thread. So if we think back to our example, and we remember from the pipeline waterfall view that scan image step was taking a while, I can kind of think, what response would you get if you pinged the security team and just said, these security scans, ever since you added them, are taking forever. I'm going to disable it. Like, hope that's okay. Or if you said, oh, you looked at the trace data and you said, oh, look, here are some links for you to look at. Security scans have been adding 15 minutes to every deployed pipeline, with 30 people committing to this repo all in the same time zone. This means our deploys are queued up and changes have been taking over an hour to hit integration for the past quarter. Here's a couple traces showing the best and worst durations. Like, one, your feelings are totally valid that this thing was getting in the way of your work and your efficiency, but you're probably going to get a lot better response from security and an actual action taken when you come with this beautiful business case backed up by tracing data. And so I think, always listen to when you feel like things are inefficient, but find the data to back that up. And so when we do this, I posit that we can actually have a lot better collaboration between developers and operators and security even, because we're going to be helping each other find the right data at the right level, and explaining it in business terms. So with all of that, thank you very much. You can find me, like I said, PagerDuty with an I, and I am happy to take questions or go back to any slide images that you would like if you'd like to take a screenshot. So thanks. Bonus. Great podcast episode. If you want to read more or hear more specifically about how GitLab has been pursuing tracing pipelines.
Cool. Thanks, Paige. And yeah, like Paige said, if y'all developed any questions during the talk, feel free to drop them in the chat or speak up. I think while people are getting their thoughts together, I was about to ask, like, how often, like, once you've got that data together, I had a question teed up talking about like the carbon-based problem, how often it's a challenge with getting humans to interact with each other. But you kind of like nailed that perfectly right at the end there. It was come at them with a valid business case, use nice words, and just ask them, right?
Yeah, and I implemented tracing for pipelines a couple companies ago, and I used it to jumpstart gathering the DORA metrics of the release frequency, of how long it was taking things, not from, I think it's from like idea or ticket to production, but at least from PR to production. That is really valuable data, especially with all this talk about developer productivity and efficiency. I'm like, oh my God, let them develop. Like it's I would not like to be under a microscope. I feel like developers are definitely under a microscope these days.
That's fair. That's that makes me kind of sad now that I think about that.
But this data can help. I'm curious if anyone, how folks here monitor the health of pipelines and CI/CD. If not tracing, is it the metrics and logs? Is it the default that comes with your provider? And do you think that tracing would be valuable?
Looking in the chat too. I will say I was a little embarrassed. Whenever I thought about observability and instrumentation, I've always thought about it as code paths. I've always thought about it as how quickly an API call gets returned.
Yes.
I mean, like, total rookie moment, I'm completely embarrassed. It never even occurred to me to attach all of that mechanism to a pipeline. Like, it's one of those things that's just immediately obvious as soon as it's said out loud. But it's fascinating, yeah.
Yeah, well, and I think we've done as an industry a lot of evolution of how we deploy over time. I use the okay, Dong, you use the default. I also use the default, but I really, as a SRE, I struggled to get that whole system view. I fought with Circle CI so much. I said, I don't care about this one pipeline. I want all of it. And I was like dreaming up ways to scrape, get API calls and scrape the data and put in my own database. And I said, what am I doing? Why don't you just you have the data, just give it to me in a format I want. Toby is thinking tracing would be valuable. I agree. And okay, you've got a Slack, Lakshmi, you've got a Slack webhook that gets a red symbol for a build ID and who triggered the build. Interesting. It's nice to have that person data, not for blaming, but if I'm on call and your deploy messed things up and paged me, I don't have the right context for that. I want to give that over to the person who's closest to the problem. Hey, a simple pipeline is a great, that's great. If your pipelines are healthy, happy, and simple, then maybe you don't need this yet. It is interesting to get that data over time, specifically of like the container image builds, because people put weird stuff in Docker images these days. Like, I got to keep an eye on that. No, it's worth experimenting with, for sure.
Yeah, and an email alert for every failed build. Yes. Again, not for blame, but just to have the data to take action.
And awareness.
Yeah.
And if you're curious more about how do you instrument for tracing, I kind of said, oh, use auto instrumentation where you can and manually instrument. At KubeCon this year, I'll be doing a workshop that's based on a Python app, and we'll instrument it for traces and add different attributes. And then if you can't make it to KubeCon, no worries. That workshop will be available online for you to do sort of self-serve as you wish.
Cool. I think you touched on it, but like people who are here who like want to get started, would like the hotel sort of docs landing page be a great place to get started with adding that instrumentation to their pipelines?
Yes, I would go to the OpenTelemetry.io. And then I think specifically, well, one, if you want to wrap your head around tracing more, they've got a section for observability concepts and a primer. That's really great to get started. And then I would honestly hop right over to the registry and just see, is your stack there? Are the components in the libraries and the languages that you use day to day, is instrumentation already there? What can I get out of the box? And start from there and explore. And then, yeah, join us, the CNCF Slack. I believe you can add yourself to get invited. That is a place where you can ask the maintainers and the developers these questions and other end users as you're exploring how to set up Hotel.
Perfect, thanks. And I'll give a quick pause if there's any other thoughts or questions from the room. I think you've awed them with content. So I think you mentioned at the start, but what's the best way for people to follow you online? I know your handle is PagerDuty on all the various socials. Is that right?
Yes, yep. I'm most active on Mastodon, but you can always reach me on LinkedIn. And then if you want to send me an email, if email is your jam, page.cruz, CRUZ, at chronosphere.io. I don't monitor email as closely as Mastodon, but I will get to it eventually. And then as an advocate, I travel around a lot of the conferences, so you'll likely see me Scale, SoCal Linux Expo, SRECon. I try to go to as many DevOps days as I can, so there's a good chance I may be coming to a city near you and would love to chat about this stuff.
Very cool. Thanks so much, Paige. And before we call it, any last thoughts, messages before we call it the end? Yep, I think it's said our
Thanks,
part.
everyone.
Cool. Thanks so much.